Hello guys, welcome to the TechoGenius Academy. So today we are here to discuss the next session on Linux system programming. We are the training providers who wants to build their career in Linux, embedded Linux, IoT, data science, artificial intelligence, machine learning and many more. So without wasting any time, let's get started. What is thread management? Multiple strands of execution in a single program are called threads. Thread is a sequence of control within a process, which means thread is a lightweight process. And thread is a single execution stream in a process which can independently schedule by the kernel. Don't be so confused. So, in a simple language, what we have done earlier, we were using interprocess communication. In that, we have used pipe, named pipe, message queues, and shared memory. What we have done there, suppose if we'll take the example of named pipe, we were creating the fork system call to create the child process. And in another program, we were creating the same. What we were doing in totally, we were creating the four processes, so means it is requiring more memory and all. Okay, but in a thread management, in a single program you can have two threads, and these two threads will be having in a single process. So what we were doing, we were creating the two processes, and only in that we were creating the four processes. That means thread is a lightweight process. In the single process, we can have a multiple threads. Okay, so the common parameters for multiple threads in a single process is resource limit, time, your PID, your PPID, timer, text section, data, signal table, and niceness value. And the different parameters of each thread is thread ID. So, what is PID? PPID means it's a parent ID or parent process ID and the process ID. Means in a single process, okay, your process ID will be the same in a multiple thread because you are running in a single process, but your thread ID will be different because there are multiple threads in that. Okay, and stack pointer, program counter, you know that what is that. When we are calling some function and that call, like the address is saved into some in some address in memory location and all, so in that stack pointer, program counter will come. So where it is storing, it's like in a stack pointer, right? So, what are the benefits and the drawbacks of the threads management is? In advantages are switching between the thread requires the operating system. Okay, so it's like a very minimum requirement of operating system is there, and it'll do so much less work than switching between the process and all. Okay, sometime it is very useful to make a program appear to do two things at once, right? So in a single process we are doing writing and we are reading too, so that is a very quiet and awesome thing. Thread takes less time to terminate, and thread consume less resource, and it takes less time to create the thread other than the process. These are the advantages, and the disadvantages, interaction between the threads are very hard to control. Suppose like in a main program you are having multiple threads. One thread is writing the data and other thread is reading the data and all. So if there is some clash between that, so you need to use some synchronization techniques and all. So you need to control very properly and all. What is thread synchronization, how we can use that, we will go deep into that in a later sessions. So what are the thread functions we can use to create the thread? So what we will do, I will write a simple thread function where thread program. We will use all these functions to explain you like in a deep like how threads are working and all. So first is a pthread create. It will create the new thread. Okay. Pthread create function start a new thread in a calling process, and the new thread start execution by invoking start routine. Okay, and argument is passed as a sole argument of the start routine. Okay, so the start routine is your thread function name. Okay, so pthread join, it is useful for waiting for another thread compilation. Means pthread join is like we have to write in a main function. Means if you are writing a thread function, it is doing their work and all before and if we are writing pthread join, it is waiting to complete of that particular thread, and main is your main function is your main thread, so it is waiting over there. Pthread exit will terminate the calling thread, and pthread self will provide you the thread ID. Important notes to be taken care is you need to include the header file pthread.h, and when you'll execute the program, you need to use -lp thread or pthread. New thread terminates in one of the following ways. It calls pthread exit. It returns from the start routine, means your thread function, and it is cancelled by the another kill or end or any other thing. So without wasting any time, we'll go to the terminal. Let me increase the size. Yep. CD, Linux, system programming. Yep. So what we'll do, we'll just create a directory here. Threads. Great. So now, we will use all these thread functions and all. The important note you need to take care is like I'll just write it down so you will have the idea. Thread dot c note in threads main thread should be alive when subthreads are completed their work. If main thread completed, then you can say all your subthreads are completed. So this is very important note you need to take care. So what we will do now, I just need to check once. Yep. So we can use hash include stereo.h. Okay, 1 second. Yep. Hash include pthread.h int main we'll just create the pthread create. We are just creating a new thread. T1 Pthread create address of T1 will pass null here, and your thread function and argument you can pass null. Main function T1, this is the main thread. I can just print, hey, welcome to the TechoGenius Academy. Pthread join T1, and we can pass null here. So I'm passing null here, and this I can explain you later why we are using null here, and we can try some other stuffs too. Let's close this, and now we are creating our thread function, void star thread function, void star p printf thread id %d /n. Now to print the ID, thread ID, what we can use here, pthread underscore self. Awesome. Sleep, we can, if you want to use some 5 seconds, we can use here. Okay, so this looks nice. We have used pthread create for creating the new thread. Pthread join, you know, it will wait to complete of subthreads, and we can use here pthread exit. So this looks fine to me. So now how we can run this? What I'll do this, I'll use some string over here to give you the better understanding. Exiting subthread. Nice. And how we can receive this? I'll just create one string here, some a string. So in that a string, where we will pass, because okay, yeah, pthread join is there, so we'll just write here address of a, and just for the confirmation that it came from that subthread in main after coming from subthread. Okay, so yep, everything I have written, this looks fine to me. So I'll just executing this. thread lp thread. Great, this looks fine to me. Now we are executing this. Main function, hello, welcome to the TechoGenius Academy, thread ID, and just see, in main after executing subthread. This exiting subthread came from subthread. Your thread function will just go to the code. So what we were doing, we are just doing the Pthread create, and the Pthread join is waiting over there to complete the subthread. So earlier I was using null there, but then you'll not have the idea like subthread is completed or not. So I can use Pthread exit in that I can use null and all, but you'll not have the idea and all. So that's why I've used some string over there, and in the Pthread exit I've just passed some string over there, and that's the confirmation that our subthread is completed, and in the main thread we are coming out from that loop in that main thread. So in this way you can write threads. So how we can use thread management in IPC and all. So I have given you the example of name type, right? So can we try some full duplex communication using threads? Some name type Mkfifo we can use. So what I think I will do here, IPC, yeah. So I'll just copy this header file to my threads directory. This looks fine to me. Yeah, so we can include #include pthread.h. Awesome. So now we can write FIFO1.c. Great. So I can use #include header.h. In that, what I'm gonna do here, I need to create one thread for writing the data. Okay, so I will open the Mkfifo file named pipe. I will use file descriptor to open that. It'll to open that Mkfifo file, it will return me fd, and that file descriptor I'll use as a argument in the write call. So okay, so I'll just write one thread one, yeah, thread function 1. This looks nice. I'm just writing one buffer, declaring one file descriptor, writing Mkfifo f1 great. Your mode, now I'm open f1 comma flag for read write. If it's not there, create that, and the mode. Okay, I'll use the while loop, means it will be continuous. I can write data continuously. Printf, enter the string. We can use scanf a buffer, and we can use the right call. Your file descriptor, your buffer, string length of a plus 1. So this looks fine to me. Now what I can do in the another thread, I will read that. Function 2 void star q corrector buffer, my file descriptor, another FIFO f2 I'm just opening this using the same, just changing f1 to f2. Read, write, if it's not there, create, and the mode. Yeah, so this looks fine to me. I'm using here the while loop. Here I will read this. Printf data So now what we will do, we have created our thread functions, thread 1, thread 2. Now we will write down the main thread, main function. Here I will create 2 threads, 3 thread create address of t1 null thread underscore function 1 null pthread underscore create address of t2 null thread function 2 null. And what I will do, I'll just write a while one here. It will wait over here, it will not exit. Yep, so because I'm looping in the thread 1 and thread 2, so if I'm not using, it will come out from that, and my main thread will complete and it will come out. That I don't want. So I'll just run this first to check like if there is any error or not. Thread, okay, FIFO 1 LP thread. 1 second, if I know. Yep, so see, my FIFO 1 is created. So now I'll just copy this thread function, thread program into another FIFO, another program, FIFO 2 for full duplex communication, thread underscore FIFO 2. If you are watching this video and if you have not gone through this my IPC sessions and all, please watch that, because it will give you the better idea, and for this program then you will have better understanding that how we are doing these things and all. Great. So now there, if you remember, in F2 I was reading, so here I need to write. correct. And in that, there in F1, in the first thread FIFO 1 we were using F1 for writing. Here we will use for reading. So everything looks fine to me now. So now I will use cc -o FIFO 2 -pthread. Great. So our both executable is ready now. So now what I will do here, I will just open the terminal, and in this I will execute my FIFO 1. Great. And in this I will execute my FIFO 2. Okay, enter the string in both the ways. Hey, see, and the FIFO 2, I'm receiving that. So now I will reply, hi, how are you? See, we are getting this data. So in this way, you can communicate between threads. So what is the next task for you? You need to do this exercise with shared memory, message queues, pipes, how you want to do and all. So you can just try it out. You can use semaphores also in a thread management. Okay, so our next thing is thread synchronization. So how we can handle the synchronization and all. Suppose in a main function, like there are so many doing integration and all this thing in a real world. So many guys wants to acquire that particular thread, and they were just updating some numbers and all. If they are just taking some value, they are just updating some values and all. But there is some clash, because one guy is getting one value and other guy is getting another value. So how we can synchronize between these threads and all. Okay, so that is the another thing we're gonna discuss. So that is now for this thread management. In the next session we will discuss about the thread synchronization, where we will use the locking mutex we will use to synchronize between the threads and all. Okay, so if you like this video, please don't forget to like, share and subscribe. And if you have any doubt in this, please mention the comment. Our support team will get back to me or any other tech guy to reply on the same. Thank you so much.